What is the actual test?
Okay. Settle. Listen to my words. We are going to go through these questions. We're going to try, like the Dickens, to get through this particular set of questions, excuse me, this morning, prior to the end of the class. Okay, we're gonna have to motor a little bit, but I need you guys to see some of this. This is a set of sample questions in TestNav 8, which is starting last semester, we started administering SOL tests in TestNav version 8. That's sort of irrelevant to you, it's just a software thing. It's not a thing, okay? It does look a little bit different. Did any of you guys not take an SOL last semester? Okay, so then maybe this could be your first experience with TestNav 8. It's not much different than the TestNav that you're used to. It's not much different, okay? But this is what it'll look like when you guys are in there, okay? Your name will appear here. This is where you guys check when you guys log in, okay? And it says, does your name appear in the right-hand corner of the screen? You know, that's the test person who's administering the test is always saying that to you. But you're going to look up here, okay? Right here, this little button, this exhibits button, this is your periodic table on the SOL test. So you click on that. If you want to see, for example, bromine, you click on bromine, and it pops bromine into there. Scandium, hydrogen, etc. Okay? So this is what your periodic table looks like. You can see the stair step very clearly. They do distinguish between metals and nonmetals. Remember that sitting exactly on the stair steps, and germanium and antimony, which is B, SB, these are your metalloids, okay? The exclusion to metals being over here are germanium and antimony, and of course hydrogen, which is definitely not a metal, okay? But it's left at the stair step. There's no additional information in here. And there won't be when you take the SOL test. This is TestNav 8. This is exactly what you guys will see. If you want the periodic table to go away, you can click on the X, or you can click on the exhibit button again, either way, and it'll disappear. Okay? You do have an answer eliminator. You don't like this one, so you cross it out. You've got a ruler. I have never seen a child need to use the ruler on the chemistry SOL. It comes standard on science SOLs, which is why it's on the chemistry SOL. And you do have to use it some when you do, you know, where in earth science where you have the, they're showing you the different elevations, the maps. What are those maps called with the rings? You know what I'm talking about? Yes. And so then you need a ruler so you can measure whatever. Okay, and I don't know. But anyway, so I've never seen anybody have to need the ruler. Either of them. And of course, you've got a TI-108 calculator. This is a basic 4-function calculator that is available to you. However,
what about like exponents stuff?
What about
however, your calculators, my calculators, the ones that you use every day, those will be in the room. I will hand you a calculator.
I say, because that's not sufficient.
And then I was like,
no, it's not. It's really not. I mean, it's technically...
That's like third grade stuff.
It is. And technically, you should be able to add and subtract and multiply and divide with exponents following math rules.
What about logarithms?
I know.
Yeah.
Okay?
Yeah.
So you guys will have a graphing calculator available to you. Okay? I will take my set of them in there, and they will be available to you. Okay? How do I uneliminate? There you go. All right. So let's take a look at these questions real quick. As needed, we're going to come up to some questions that we haven't seen before, and as we need to, we're going to refer to our SOL packets. Okay? So grab your couple sheets of paper. We're working our way through these questions. Everybody's working on every question.
Do you want us to write it down?
Yeah.
There's a way to like zoom in on that.
You
No.
have to draw the freaking thing.
There's not a way for me to zoom in. Oh, I lied. Now, you can't do that when you're taking the test. But I guess because we're in a practice situation. Is that more better? Zoomed in. You don't have to write down the actual question. You just write down your don't write down the question. We don't have time for that.
I said,
Write
hey,
down
you
the
have to
work.
Write these down.
No,
And
no,
you're like,
yes, you have to write it down, but just do your work. Just show your work
Miss Russell,
on your paper.
that's what.
No. We don't have time to write it down. Yes. Sure.
I wish my hands weren't cold so that my ring would fit. It changes enough that my knuckle can swell up where the ring won't come off.
What is our percent error equation? PE equals
M minus A.
M minus A
Divide
over A
times
times 100. What is the M? No. What is the value of M in this problem?
1.91.
How do you get that?
You get the average.
Get an average, yes? So measured is 1.91 minus 2.02. The quantity divided by 2.02. The quantity times 100. And they're obviously keeping one decimal place on this. So what do we like?
5.4.
Which is C, yes? Troubles?
Awesome.
All right, moving to the next question. How many sig figs will result when calculating density from these data? How many sig figs will result when calculating density from these data? Which two of those values do you need for density? Mass and volume. So, how many sig figs are here?
4.
4. How many sig figs are here?
3.
3. So, then our density should have how many? 3, because it's the smaller number. Yeah? So that question was how many sig figs?
3.
Like that's the whole question. Yeah? I don't know if I like having landed this early in the day. I think it might be a little, I don't know, something. Yeah, okay. All right, here we go. Ooh, type your answer in the box. Calculate the atomic mass of the theoretical element using the data in the table. Your answer must be rounded to the nearest tenth. Holy cow, it's been a while. Yes? Just a little bit. Okay? Now, let me find it in the packet because I think there's one in the packet. Maybe. If not, I'm going to do it for you. I didn't forgot it. I'm not seeing it. It should be under... Ooh, this is a problem. Okay. Go in your packet, please, to page... The best place to put it is actually on page 1 at the top above the krypton. So write small, but let's get it in here. Okay? I don't like to write on the back of these packet pages because you guys won't look at them. Okay? So, let's just talk about it for a second and then we'll write together on top of that page. Okay, so we're going to talk about it for a second. Who remembers how we actually do this? This thing has 3 isotopes, which the M&M lab had 3 isotopes. I know that's way back, okay? We have, for isotope 1, a mass number of 10 and a relative abundance of 92. A mass number of 11 with a relative abundance 6.5. Mass number 13, relative abundance 1.5. Anybody recall how to do this? You have to do it on Thursday by yourself.
50% in decimal first.
Okay, we get the percents into a decimal. Okay, and we actually call that relative abundance. Actually, this should say percent abundance because relative abundance is the percent, not in decimal form. Okay? Now, I don't think I can write on the screen. I haven't been able to in the past. Mother of pearl. Magic. Okay. So,
Yeah, that's not what it is.
okay, make yourself a note so you have this data. At the top on your packet, write small, write small. Calculate the average atomic mass. Just put that. Calculate the average atomic mass. And then very quickly summarize this chart. You don't need all the rest of it to the nearest tenth, blah, blah. You don't need isotope data. Just summarize this chart. And leave some space to do the math. It'll be about 3 lines or so underneath or to the side.
So you said that up there is supposed to be percent abundance?
The way it's written, it really should be percent abundance, yes. Because when we do relative abundance, it's a decimal. If you're at home working on this, we're adding this to the packet right here. That's where we're writing right now. Okay, so Bradley says we take the percents and we make them into decimals, which is true. We move the decimal 2 places to the left. The other way to think about it is whenever we make something into a percent, we multiply by 100 so you can divide by 100, which moves the decimal 2 places to the left. Yes? Okay? So this, for this relative abundance, it's going to be 0.92. This relative abundance is going to be 0.065. This relative abundance is going to be 0.015. Fair enough? We good? Okay, now, anybody remember what we do next? What do we do with the 0.92, the 0.065, etc.? Well, this is just numbering them. What do we, yes, we put them together with what? The mass number, okay? So for this one, there are 3, so we need 3 portions, if you will, to figure out, and then we add them together. So we're going to take 10 times 0.92. We're going to take 11 times 0.065. And we're going to take 13 times 0.015. You take the mass for that isotope, multiply it by its relative abundance. The mass of this isotope multiplied by its relative abundance. If there's 2 isotopes, you do it twice. If there's 9 isotopes, you do it 9 times. When we did M&M lab, we did it 3 times because we had 3 isotopes of M&M. Okay, so 10 times 0.92, 9.2, 11 times 0.065, then we add them up. add this, but what would be the unit on this? Good. We don't have to add that because it's a Dropbox question, but it would be AMUs. And they said your answer must be rounded to the nearest tenth. So what are we gonna put as our final answer in the box? 10.1. Troubles? Is it coming back to you? All right. I think I probably need to erase.
What was I thinking? You get an element and you have the isotopes attached to them, and it says which one occurs more. Like, I guess the one is closer to the real atomic mass.
Yes. Did you guys hear Landon's question? So did you have that on a JLab?
Yeah.
Yeah. So remember, okay, everybody grab your periodic table and take a look-see at your periodic table. Find sulfur.
Got it.
Sulfur occurs in nature in two major forms. Sulfur 32, which has a mass of 32, and sulfur 34, which has a mass of 34. The difference is the mass. The difference is the number of neutrons. That's what makes one isotope different from another. If you add neutrons or take them away, you get heavier or lighter by one every time. Okay? So sulfur occurs in nature in two isotopes. Sulfur 32 and sulfur 34. Which of the two isotopes occurs most often in nature?
32.
Sulfur 32. Why?
Because that's closer to what this period?
Because the atomic mass on the periodic table is 32.07. So it occurs most often with a mass of 32. Very rarely with a mass of 34. Yes? Hydrogen exists in nature in three forms. Hydrogen 1, hydrogen 2, hydrogen 3. Based on what's on the periodic table, Landon, hydrogen 1 is the most common or abundant naturally occurring isotope, yes? Because the mass of hydrogen on the periodic table is 1. Yes? 1.01. Good question. All right, here we go. Next one. Holy smokes. Hello. Characteristics of different sulfur atoms. Different sulfur atoms.
Is these data correct English?
Yes.
But from this data sounds right as well.
I hate English.
From the data. What conclusion can be made from this data, from these data? From the
It's
data?
multiple data points.
These datas.
Data is singular and plural.
Dumb.
I mean, I didn't know.
I know.
Okay? Yeah, it's like moose and moose. Moose and meese.
I understand deer though.
Deer and deer. I know.
I understand it. Because I never. But
Man, you should see this deer that hangs out all alone in my backyard.
yeah,
Man, you should see these deer.
I know.
The whole herd of them that
I've
hang
just
out
never.
in my backyard.
I've never heard data be plural.
It is. It's singular and plural.
Data.
Okay. We're focused. People! Focus.
These calculated.
We don't actually need the data set to understand what is the correct answer.
Hey,
A. Why?
there's never a neutron.
Because this is the same, and these are different numbers each time, yes?
Yes.
Okay? Alright, groovy. Moving on. Okay,
What?
okay, chill.
Shit.
It's not. Fish is it's fish.
Let it go.
Before we let it go, is it fish or fishes?
Either is correct. All right, listen up. We need to do something real quick. Get a blank sheet of paper.
Blank.
Get a blank sheet of paper.
Miss Wells did. Did we not learn it? We didn't learn it, did we? What did she say? No. Ability of chemistry.
Totally blank sheet of paper. I'm going to squeeze this onto this little nugget of space right here. Okay? Title your paper. Nice and large at the top. You don't have to write small as me because you can write it nice and large.
I really like the way that my C connects to my H in chemistry, but I know that I can never make it happen again.
Okay.
And that hurts me.
You're a little froggy in the mornings
I
already
am.
too.
I'm like, listen.
First block gets it out of
All right, here we go.
Who does?
you.
Train tracks.
Train tracks?
Who remembers train tracks?
Me.
What's a train track?
King. No. King. Yeah. King Henry died. Is drinking chocolate milk.
Jot it down.
Jot it down.
Density circle.
DM over me.
I like the circle.
That looks good.
It looks like a speech bubble.
If we need density, what's the equation?
D
If we need density, we need
Oh,
mass over volume. If we need volume, it is
Mass over.
mass divided by D. If we need mass, it is
Density.
D times V. Okay? We've already done it once, but we're going to write it on our scrap paper. Percent error is M minus A over A times 100.
When it comes to getting our scrap paper when we get in there, are we allowed to just start writing or do we have to wait till the test starts?
Did you guys hear Shoop's question? When you get into the SOL test, he asked, when you get in there and the scrap paper is at your table, or you're going through the part in the instructions where you pass out the scrap paper, whatever, can you go ahead and start writing? No. If you write prior to being told to begin the test, then we have to take whatever you've written on and we have to confiscate it, basically. So, as soon as you are told you may begin, work till the end, raise your hand when you're finished, we've already gone through the practice problems together, the example problems at the front of the test. At that point, when we say go and we stop talking to you, then you can write anything you want on your scrap paper. And I'm going to suggest, you guys are going to have a little bit of homework here tonight, and I'll talk to you about that in just a second. But I'm going to suggest that you recreate your scrap paper. You recreate what we're doing right now as soon as the test begins. Okay? There's not a whole lot that needs to go on there. And most of it you know, but it's going to be a good reference for you. Okay? So, train tracks, density circle, percent error. Next. It's been a while on this. Electron configurations. You need to know 3 rules. We're not going to put them on our scrap paper. You just need to study those. So let's remember electron configuration. I'm going to put it over here. It doesn't matter where you put it. Okay? And take your time. Remember, you're going to need 1s, 2s,
2p.
3p,
3S, 3P.
3s, 3p. Remember? This is helium. We get up to 10. This is neon. You get 8 more. This is argon. Review the 3 rules real quick. Off-ball principle says,
So at the bottom.
start at the bottom, lowest energy level first. Pauli exclusion principle has 2 parts. 2 parts. No more than 2 electrons in a box
And it has to be an arrow.
if 2 opposite spins. Yes? And we show that up arrow, down arrow if we're in the same box. And then the last one is Hund's rule. Hund's rule says
It will occupy by itself first instead of pairing.
unpaired first. Yes? Hund's rule is unpaired first. Okay? I'm erasing just for space. You don't have to. Just keep adding.
I was excited to see you get that all crammed in.
Yeah, I can't do that. Okay? Next.
Oh.
Next one, super important.
Mm.
Oh, yeah.
Electromagnetivity, atomic, something, and ionization. What's the atomic something? Atomic radius. That's what it is.
Sounds like a 1
I didn't make my box big enough. Trend 1. As you move up, as you move left, right. Atomic radius decreases. Two. Ionization energy increases. As you move up, as you move left, right, increases. Big one.
Electronegativity.
Remember, the consonants go together. Radius decreases. Ionization energy increases. All vowels. Electronegativity increases. All vowels. Yes? And you got to remember, up and left, right. Okay? Now, that brings us to this particular question. Okay? Which element has atoms that most likely have the greatest shielding effect? Okay? Shielding effect is not something that we teach typically, okay? But shielding effect follows the same trend as ionization energy and electronegativity. So, that being said, grab your periodic table, find barium, strontium, calcium, magnesium.
Gotcha.
Where are barium, strontium, calcium, magnesium?
2.
They're like this. So, if shielding effect increases as you move up and increases as you move left, right, which one has the greatest shielding effect? Magnesium, because it is the highest? Good. You with me? Okay, let's add something else to our scrap paper. Ideal gas law. PV equals nRT. Good. Where R equals 8.31 always. That's the ideal gas constant. What's molarity?
Oh, I know this. I do.
You weren't here.
I do. It's
You hush.
no, it's something.
You hush.
by
People
liters.
that were here.
Mold divided by liters.
Michael Rush, what did I say?
I'm just saying. I wasn't here. I know.
Last one.
You looking for the definition?
No, equation. What do we do to get calories?
Joules? There's something to do with joules, right?
No.
Well,
Degree Celsius change. Yes? Now, let me see yours. All right, we got train tracks, density, percent error, electron configurations, mole conversions, periodic trends, which is the periodic table, ideal gas law, molarity, calories. 9 items. Yes? 9 items on our chemistry scrap paper. Okay? Now, here is your homework assignment. Listen to my words. I want you to recreate the chemistry scrap paper. That means you take a new sheet of paper and you recreate what's on there 5 times between now and Wednesday afternoon. I'm not going to see you again until Wednesday afternoon. So when you leave here, you go to 4th block and you spend the afternoon in 1st. Tomorrow you're in 1st and 2nd all day. Wednesday, you start the day in 2nd block, taking the SOL 2nd block test. Then you're with me the whole afternoon. So I'm not going to see you until Wednesday at normal class time, actually. Well, 11:55. Wednesday, we're together all afternoon. Okay? So, your homework assignment. This is a written homework assignment. You will give to me, when you walk into class on Wednesday, your chemistry scrap paper with these 9 items on it. You will give me 6 handwritten copies. 1 you just did. Do you follow? Listen to my words. I am begging you. Begging you. write it 2 more times tonight, which is Monday. Write your 3 additional on tomorrow night. Yes? Please. It will stick better if you space it out. Do you understand? Do it 2 more times today. We just did it once. Do it 2 more times today for a total of 3 by the end of today. And then do it 3 times tomorrow. And if you can space it out during the day tomorrow, that would be best. Like in the morning, and then again after school, and then again right before bed. Yes? I mean, there's no way for me to verify that, but it's going to serve you better
What's
to
the
do that.
schedule on Wednesday? Something's on the third.
Second block all morning, third all afternoon. That's it for Wednesday. All right, we'll work on more of these practice problems on Wednesday, and then we're going to work on these for a little while, and then we will spend the rest of the afternoon Wednesday playing SOL football,
Oh, nice. Football.
which is my review game that I invented. You'll be split into 2 teams. We will have a football, and we will play SOL football. You guys will be competing against each other for extra credit. By the way, let me go ahead and say this so you guys can be thinking about it. You need to have something to tie-dye. Listen to my words. Listen to my words. We will do day 1 of tie-dye on Monday of next week. Day 1 of tie-dye on Monday of next week. Day 2 on Tuesday. Finish and be done on Wednesday. It is in total a test grade. Okay? Really, the only way that you get bad grades on tie-dye is you don't bring something to tie-dye on time, and so then you end up with a 50 because it's late, and that happens. The other way is that you start it, but then for some reason you decide that you're never going to show up for chemistry again, and you never finish it, and then you get zeros for those days. Okay? Now, listen to my words. The item that you bring must be cotton. No polyester, no silk, no cotton poly, cotton acrylic blend. Cotton. 100% cotton. Listen to my words. 100% cotton. It must be white. Not pale gray. You see Grayson Peary's shirt. Is that white or is that an ashy gray?
It's white.
Does anybody have that real pale ashy gray shirt on today? You know what I'm talking about? It's almost white, but it's like, no. You put tie-dye on that, it turns up brown. I don't know why it's a thing, so don't even do that, okay? Now, I will tell you, you need not buy a brand new item. It can be something that you have. It cannot be underwear. It cannot be socks. It needs to be a t-shirt. Or it can be a pillowcase if you have a white jersey knit pillowcase. Jersey knit is the weave that we use to make t-shirts. It's called jersey knit. And they actually do make bed sheets in jersey knit, which are awesome. If you've never had t-shirt sheets, they're magic. You'll bring a bed sheet up in here, okay? Ms. Russell buys the dye herself. I'm not buying gallons of dye so you can tie-dye your bed sheets, okay? You'll learn the technique. You can go buy the stuff on your own to do it, okay? But if you want to buy a jersey knit pillowcase, they have those, and you could do one of those. Ideally, you need to have it here by Friday. That way you don't have to worry about it. You need to have something here by Friday. It needs to be in a gallon Ziploc bag with your name on it. This is important. We actually use the Ziploc bag several times through the process. Okay? It needs to be, please, Lord, they're all going to take a bath together the first day. It needs to be clean.
Love me a
It needs to be white, but it can have a print on it. So, Grayson's t-shirt, for example, if she wanted to tie-dye that t-shirt, she could. It can have a screen print. The screen print will remain true. So, if you have an old, I don't know, field day
Vote for Paris t-shirt.
t-shirt, I mean, I don't know, whatever.
I was thinking about it.
Okay, so you can tie-dye. It does not have to be brand new. If any of you guys are in a situation where getting a white jersey knit 100% cotton t-shirt is a problem for you, you need to have a conversation with me. A private conversation with me, and I will make that happen. If you don't, and then you come in here and you don't have it ready to go, then you're going to get late credit. I don't have any, you know, own your situation. Okay, we'll talk about it. I'll get a t-shirt for you. It may be out of my drawer at home, but it'll be white, it'll be clean. May have God knows what print on it, whatever. But I'll get you a shirt, okay? But you've got to talk to me about it. Capiche? Got to have that by Friday in a gallon Ziploc bag with your name in Sharpie on the gallon Ziploc bag. Capiche?
Yas.
Scrap paper, 5 additional times, 6 total by the start of class Wednesday, and start of class Wednesday is normal class time. It's 11:55. Yes?
So that means that Wednesday is what?